Good evening all. Welcome to ACE Engineering Academy and online platform ACE Online. It is pleasure to introduce myself, K. Hanumantha Rao, faculty in electrical department. Guys, today we are going to discuss and interact with your favorite subject for electrical engineers under electrical engineering for any competitive examination, network theory or electrical circuits. The title for this today, tsgenco, it was given electrical circuit. A revision session we are going to discuss about this under electrical engineering. Guys, today the total 1 hour or 1 hour 15 minutes, the entire duration, I would like to divide with some of the important topics. Those important topics I would like to list out here. The first one is last session which I have taken under tsgenco notification. ఆ నోటిఫికేషన్లో సిలబస్ మన కోర్ సబ్జెక్ట్లో కూడా కొన్ని యాడ్ అయ్యి ఉన్నాయి. ఆ అడిషన్స్ ఏంటో అవి కూడా ఈరోజు ఒక 5 minutes I would like to discuss. And after that, I want to take that additional syllabus. ఈ tsgencoకి అసలు అడిషనల్ సిలబస్ ఏమేంటి అంటే ఫ్రమ్ 2015-2023 there is no tsgenco notification. ఆ 2015ది అండ్ 2023ది రెండు సిలబస్ని కంపేర్ చేస్తూ ఒక 5 minutesని నేను మీతో డిస్కస్ చేస్తాను. ఓకే, what are the differences or what syllabus is added? What is the additional syllabus which was added in tsgenco notification? Additional syllabus తర్వాత రివిజన్ సెషన్ ఫర్ ఎలక్ట్రికల్ సర్క్యూట్స్. దట్ ఈస్ ద మేజర్ టాపిక్ టుడే వీఆర్ గోయింగ్ టు డిస్కస్ అబౌట్ దిస్. And after that, model questions also. Guys, ఈ తక్కువ టైంలో ఉన్న టయాన్ని నేను ఫస్ట్ సిలబస్ టాపిక్ వైజ్ తీసుకొని ఇంపార్టెంట్ కాన్సెప్ట్స్ని నథింగ్ బట్ సమ్మరీ ఆఫ్ ఈచ్ అండ్ ఎవ్రీ టాపిక్ని ఎక్స్ప్లెయిన్ చేస్తూ ఆ ఈచ్ అండ్ ఎవ్రీ చాప్టర్ కింద ప్రీవియస్ ఎగ్జామినేషన్ క్వశ్చన్స్ tsgenco అండ్ 15 క్వశ్చన్స్ని అండ్ ట్రాన్స్కో క్వశ్చన్స్, ఎన్పిడిసిఎల్ క్వశ్చన్స్, ఎస్పిడిసిఎల్ క్వశ్చన్స్ ఫర్ ఈచ్ అండ్ ఎవ్రీ చాప్టర్కి 2 or 3 క్వశ్చన్స్ని డిస్కస్ చేస్తాను. ఇంపార్టెంట్ చాప్టర్స్ని డిస్కస్ చేస్తానండి, ప్రీవియస్ ఎగ్జామినేషన్ క్వశ్చన్స్ని. రైట్, ఆ టాపిక్లో ఇంపార్టెంట్ టాపిక్స్ యాజ్ వెల్ యాజ్ ద మోడల్ క్వశ్చన్స్ విచ్ ఆర్ గివెన్ ఇన్ ద ప్రీవియస్ PSUs, public sector undertakings like GENCO, TRANSCO and ISRO, NPTCL, SPTCL. Those questions we will discuss. And finally, student interaction. This is the today's session, the highlights I am going to take for 1 hour or 1 hour 15 minutes or 1 hour 20 minutes also. It may take time, right? Without wasting the time, I would like to start with that syllabus modification, this tsgenco 2023, right? As you know that the exam is on December 3rd అని మీకు తెలుసు. ఈవెన్ దో ఎలక్షన్స్ కూడా అనౌన్స్ అయిపోయింది ఫ్రమ్ ద ఎలక్షన్ కమిషన్. ఎలక్షన్ ఫర్ తెలంగాణ 30th November ఉంటుంది అండ్ కౌంటింగ్ 3rd ఇచ్చాడు. బట్ ఎగ్జామినేషన్ అయితే పోస్ట్పోన్ కాదండి, 99% పోస్ట్పోన్ కాదు. ఇట్ ఈస్ నాట్ ద ఎలక్షన్ డేట్ అట్ December 3rd. ఎలక్షన్ డేట్ ఈజ్ November 30th అండ్ కౌంటింగ్ డేట్ ఈజ్ ఆన్ December 3rd. దట్స్ వై కౌంటింగ్ డేట్కి మనకి ప్రాబ్లం ఉండదు కాబట్టి ఎగ్జామ్ యాజ్ యూజువల్గా సండే జరుగుతుంది. నాట్ ఏ ప్రాబ్లం, ఐ థింక్ సో. 99.9%. ఎందుకు ఇది అంటున్నానంటే నోటిఫికేషన్లో వాడు ఇట్ మే చేంజ్ అన్నాడు, బట్ ఐ డోంట్ థింక్ సో. 99% ఆన్ 3rd ఉంటుంది. ఓకే, లెట్ మీ స్టార్ట్ విత్ దట్. అండర్ ద tsgenco సిలబస్ 2023లో ఇచ్చింది ఫస్ట్ సబ్జెక్ట్ ఎలక్ట్రికల్ మెటీరియల్ ఇచ్చాడండి. ఇది న్యూ సబ్జెక్ట్ అనమాట. ఐ థింక్ ఆల్రెడీ ఎస్టర్డే సమ్ ఆఫ్ మై ఫ్రెండ్స్ ఆల్రెడీ స్టూడెంట్స్ ఆర్ వాచ్డ్ ద వీడియో. మిస్టర్ Madhusekar sir was given electrical materials, the preparation strategy was given. It was excellent, and if you want to see those who are not watched, you can watch. Yesterday it was the entire syllabus, how many questions, what are the important concepts, everything he was explained, right? And this is the new subject. Compulsory, one or two questions you will get it here. 2 questions or 3 questions you will get it on this one. This is the new subject for 2023. It was not there in 2015, right? Let me take the next one. Next one is our subject, electrical circuits and fields. ఇక్కడ ఫీల్డ్స్ అనే దాన్ని ఒకటి యాడ్ చేశాడండి. దిస్ ఈజ్ ద న్యూ సబ్జెక్ట్ అండర్ ది 2023 TSGENCO సిలబస్లో, రైట్? ఈఎంఎఫ్ అనే సబ్జెక్ట్ అనేది న్యూ సిలబస్, అండ్ ఎలక్ట్రికల్ మెటీరియల్స్ కూడా వీఆర్ ప్రొవైడింగ్ వాట్ ఎవర్ ద బ్యాచ్ విచ్ వాస్ స్టార్టెడ్ ఆన్ 7th. వీఆర్ టేకింగ్ ద క్లాసెస్ ఫర్ మెకానికల్ సబ్జెక్ట్స్ ఆల్సో parallelly. That's why here for EMF also we are going to provide. అండ్ వైల్ కమింగ్ టు దట్, ఇప్పుడు ఎగ్జాక్ట్లీ ఈ సిలబస్ నేను డిస్ప్లే చేస్తానండి. ఫైనల్గా వన్స్ ద ఎంటైర్ సిలబస్ ఈజ్ కంప్లీటెడ్, ఫైనల్లీ ఏమేం మోడిఫికేషన్ అనేది ఒక టేబుల్ వేసేసాను. దెన్ యూ కెన్ గెట్ దట్ డీటెయిల్ మోడిఫికేషన్ అండ్ అడిషన్ సిలబస్ ఫర్ దట్ వన్. ఓకే, and this is the 2015 for electrical circuits. There was no electrical field. EMF is the new subject. And while coming to that, the next one, electrical and electronic measurements. And measurements and instrumentation, it was given, the title was like that, and electrical and electronic measurements. And what are the differences? I will give that the entire syllabus is completed. I will give that. What is the difference? And the next one is analog and digital communication, digital electronics. Now in this analog communication is also, digital communication also is given. That I will give that separately. What is the added topics for the existing subjects also, for these subjects. Okay. And while coming to the next one is the systems and signal processing. This is the new subject, already expected one, right? And the next one is control system, and what are the additional topics, some of the few topics are given. That also I will give that separately. Next one is electrical machines. I think what are the modifications, everything I will provide. Power systems in this one also. Next one is power plant engineering. Next one is power electronics and drives. Here drives, some of the drives are given, the difference also I have provided in the table. This is 2023 GENCO syllabus, 2015 GENCO syllabus. And thermodynamics, this is the new subject here. This is related with the mechanical. And while coming to that, heat transfer is also, this is also new subject. And while coming to that, that is the section A and section B. I think section B there is no changes here. That's why under remarks I have taken, there is no changes for section B. Nothing but what? Non-technical. Number of questions, number of marks are same. Everything, syllabus is, everything is same. Right? And while coming to that here, this is the additional syllabus, additional subjects and topics in 2023 which was added. Electrical materials, which is the new subject in this one. This is the new subject. And electrical circuits, graph theory, usually filter concepts, graph theory, I used to give that some of the year 4 hours for this one, 2 hours for this one. Usually, even though it was not there for 2015, there are and at that instant also I have provided the notes related with the graph theory as well as basic filter concepts I have given. And EMF is the new subject. And electrical and electronic measurements, principle of measurements and accuracy, precision, standard error analysis, potentiometer, DVM, and phase time and frequency measurement, Q meters, potentiometer recorders, basics of sensors. These are the some of the additional topics which are given for this one. These are the some of the additional topics which are given. You can identify here. And while coming to that analog and digital circuits, basic filter circuits, applications, sample active filters, and sample and hold circuits also given. Simple active filters. This is the additional part here which we have identified for 2015 నుంచి 2023 కి. మైక్రోప్రాసెసర్లో దానిలో కూడా ఉంది ఇంటర్ఫేస్ అండ్ అప్లికేషన్స్ ఆర్ గివెన్. అండ్ వైల్ కమింగ్ టు దట్ ద అనలాగ్ కమ్యూనికేషన్, linear integrated circuit, analog communication basics and modulation, demodulation. This part is somewhat electronics part, purely electronics part here. This is also we are going to cover when the batch was started on 7th. Last week batch was started on 7th. For them we are providing the entire additional syllabus also. And the additional syllabus we have started one online course also. Online batch we have started. You can also enroll with that. If you enroll, definitely you can get the, you can complete the entire syllabus within 15-20 days. You can syllabus. You can complete that. This is the good opportunity for those who are completed, those who are joined in ACE Engineering Academy for GENCO Transco batch. If you take that live batch, then you can cover entire thing. We have started that batch also. Remember that. Online batch. There is no offline batch for separate syllabus. Additional syllabus ki offline batch we have not started. Since we are going to provide whatever the batch which was started on 7th, for them we are going to provide the additional subjects. Aa batch ki additional subjects ni provide chestunnam kabatti we are not providing any additional batch, physical batch provide cheyatledu, but online batch we are providing that. Additional course online batch we are providing, and recorded also we are trying to announce within 2 or 3 days. Definitely recorded lectures kuda additional courses ni evaithe mechanical courses unnayo aa courses ni recorded lectures ni if you want to get it then we are going to announce that within 2 or 3 days, right? That one also. And control system, minor changes are there. While coming to that power system, these are the changes which you can take it. దీనిలో maximum ఈక్వల్ గానే ఉంటుందండి. And while coming to that power electronics devices లో these are the additional topics ante existing one only, everybody knows that, but you need to, he was given that for 2023 if you compare for 2015 avi compare chesinappudu these are the major differences which you have identified. And this is the thermodynamics is the new subject and heat transfer is the new subject. For this we are providing, no doubt, online course we are providing, offline also we are providing. Those who are joined on 7th, and if you want to join, you can join, right? We will provide these additional subjects also, physical batch. There is no special batch for only the additional subjects, right? These are the some of the changes which we have identified, because last session which I have given regarding the notification, some of the students they want the what exactly the difference or syllabus from 2015 to 2022 వాళ్ళు అడిగారు. For them this I am providing for them. Okay, now let us start that actual session. Today's session is the revision session for electrical circuits. Revision session for the electrical circuits. Okay, now ఈ రివిజన్ సెషన్లో నేనేం చేస్తానంటే ఈచ్ అండ్ ఎవ్రీ టాపిక్కి అకార్డింగ్ టు ద సిలబస్, ఏ సిలబస్ జిన్కో ప్రకారం, టీఎస్ జెన్కో 2023 నోటిఫికేషన్ ప్రకారం ఆ సిలబస్ ఏంటిది ఫస్ట్, అండ్ ఐ విల్ కంపేర్ దట్. ఐ విల్ ప్రొవైడ్ వాట్ ఈస్ ద వెయిటేజ్ ఫర్ ఎలక్ట్రికల్ సర్క్యూట్స్ ఫ్రమ్ పాస్ట్ 10 years. 10 years అంటే 2014లో టీఎస్, 15లో టీఎస్ జెన్కోలో టీఎస్ జెన్కో గివెన్ అండ్ ట్రాన్స్కో గివెన్, and NPDCL, SPDCL, AP GENCO, AP Transco given. That's why what are the weightage given for this subject, electrical circuit subjects ki enta weightage ichesadu avanni manam discuss cheddam. Then after that we will take chapter wise and I will provide the highlights and I will give that model questions. Okay, right. Now this is the syllabus as per the TS GENCO 2023 year. Circuit elements, network graph, KCL, KVL, node and mesh analysis, ideal current and voltage sources. While coming to that, next one is the theorem. So Thevenin's Norton superposition maximum power transfer theorem. transient response for DC as well as AC given, sinusoidal steady state analysis, this is AC circuit analysis. Now the basic filter concepts is given here, this was not there, and two-port networks are there, three-phase circuits are there, and resonance is there, magnetically coupled circuits are there, and graph theory also is there. These are very simple topics, you need not worry about that electrical circuit syllabus here. I can give the guarantee for you, you may not get that much of difficult questions under network graph as well as filter concepts, right? And while coming to that here, the weightage which was given in the previous PSUs, previous years lo, enta weightage ichchadu, weightage of electrical circuit subject. 2017లో ఏపీ జెన్కో ఏపీ ట్రాన్స్కోలో 9-6 ఇచ్చేసాడు. 2018లో టీఎస్ జెన్కో టీఎస్ ట్రాన్స్కో టీఎస్ ఎస్పీడీసీఎల్ 11-9 ఇచ్చేసాడు. 2019లో ఏపీ ట్రాన్స్కో ఏపీ ఈపీడీసీఎల్ 11-10 ఇచ్చేసాడు. అండ్ 22లో టీఎస్ ఎస్పీడీసీఎల్ ఎన్పీడీసీఎల్ ఎస్పీడీసీఎల్లో 15 క్వశ్చన్స్ ఇచ్చేసాడండి లాస్ట్ టైం, రైట్? Last year it was given that SPDCL 15 questions, 9 questions. According to this, I can say that on average 8 to 10 questions. Nothing but 10 questions minimum రావచ్చు. 8 to 10 questions అయితే కంపల్సరీగా ఇస్తాడు. ఈ 8 to 10 questions-లో what are the basics or what are the main important topics for electrical circuit subjects? What are the main important topics for the electrical circuit subject? Let us take that one by one. Now while coming to that here, the weightage which was given that for topic wise, important topics, see this one, right? DC circuit analysis అంటే basic terminology. ఈ basic terminology లో 40% ఉంటుంది, and AC analysis 40% ఉంటుంది, network theorems compulsory question 10%, and two-port network parameters, graph theory, filters ఏమో 10%. Maybe one question, 2 questions or 3 questions రావచ్చు, right? And this is the major chapters or major concepts, major topics under electrical circuits, right? While coming to that, the prerequisite, you should have that some mathematics basics and physics concepts which you have learned in the +2 level, right? Let us see that these are the, I would like to take that the reference books. These are the 3 books you need to take it. But ఇప్పుడు books తీసుకుంటే you need not go for that. But why I have provided the books means, ఎందుకు books provide చేశానంటే, suppose some of the students they are very much bother about that some of the topics, difficult topicsకి వాళ్ళు ఫీల్ అవుతుంటారు అనమాట. దట్స్ వై కొన్ని difficult topics if you are having any here, this is Sudhakar and Shyam Mohan is the easy language, easy terminology, you can get it. From the easy terminology, you can get it, suppose you are difficult with the transient topic, you can take it that. You are feeling that difficult in transient topic, you can take it that Alexander and Sadiq. These are the 2 books you can take it. Now, only the specific topics and any topics, all the topics you need not go for that. All the topics you need not go for that. Is it right? You need not go for all the topics, only specific topics ki either this Alexander and Sadikyu or Sudhakar and Shyam Mohan you can take it. Or you need not refer this book, whatever the material you have provided, that is more than enough. Those who are preparing self-preparation, you can refer these 2 textbooks for electrical circuit subject, okay? Now while coming to that our ACE publications, we are providing that ACE publications. First time here previous examination questions. This is the previous examination question and this is the classroom practice questions. Apart from this, if you want to check with that more questions here and SSC JE, for SSC JE also we are providing here the training or the coaching. That's why from this one also you can get it PSU questions. That's why these are the 3 books we are providing for GENCO and TRANSCO and PSUs, public sector undertakings, right? These are these publications, okay? Now let us take that one by one here, right? Now chapter 1, these are the main topics you are having that in basic terminology, like in whatever I have given that way under weightage DC analysis. Under DC analysis means basic term analysis. DC analysis means basic term analysis. First one is importance of Ohm's law for circuits, Kirchhoff laws, equivalent circuits, analysis and circuit analysis using nodal analysis, mesh analysis, source transformation technique, power calculations by using intelligence theorem. Summary of the basic terminology here. In these guys, I can say that you will get minimum 3 marks, you will get it here. 2 to 3 marks you will get it. For the first here, 2 to 3 questions you will get it. Or every question having only 1 mark, na? 2 to 3 marks you will get it under what? Basic terminology, which is what? DC circuit analysis, which contains 40%. Minimum 3 marks you will get it here. 2 to 3 marks you will get it. And while coming to that, what are the summary of the basic terminology? Guys, this is very important for the students, all those who are preparing for coming GENCO examination. One thing I can remind you, that is, what it is, while you are preparing for this one, you make a short notes, because for each and every student, short notes is separate. Suppose you are having some difficult topics according to your knowledge, those only you have to prepare for that one. That's why what are the main important concepts or the summary of the basic terminology, if you take it, these are the important or the summary revision, I can take it that. This is the revision. Classification of network elements. 5 types of the classification based on the characteristics and behavior, and what you take that? Behavior, characteristics. Based on this, I can take it here. These are the 5 categories: linear, non-linear, active, passive, bilateral, unilateral, and lumped and distributed elements, time variant and time invariant element. And while coming to that, the next one. Guys, in DC circuit analysis, I can say that this is whatever the 2 scenarios which we need to learn, which we have to follow throughout our entire your network theory or electrical circuit topics. This is how you have to take the conventions when the presence of sources and absence of sources. These are the 2 you have to take it here: presence of sources and absence of sources. While coming to that here, regarding that passive elements, sometimes here, suppose very simple questions you may ask that. On that time, you have to remember this resistor material and examples, like that inductor also. Suppose if you are considering that inductor material and examples also, these are important. Sometimes you may get questions. And inductor applications also, sometimes you may provide. These are the inductor applications. Like that capacitor, I am providing that capacitor material, dielectric material, and examples, whatever the examples under capacitor. Like that, I can say that the applications of the capacitors, these are also very important. While coming to that, the next part here, in this one question compulsory here. You will get 1 question compulsory. Here 1 question compulsory. This is very, very important. This is very, very important. Equivalent circuits with respect to passive elements. Under that, we have 7 methods are there: series, parallel, bridge balanced, star delta conversion, ladder networks, parallel symmetry, perpendicular symmetry, VA method, 1 ampere, 1 volt method, right? Now, while coming to that here, next one is the source transformation technique here. Under the source transformation technique, you know that source transformation technique is not applicable for ideal sources. It is applicable only for the practical sources. And while taking that here, source, whatever the modification we are doing across the load circuit, this is the load circuit here. This is the modification we need to do for this part from voltage source to the current source, which can be voltage source to the current source. What is the current source value? Vs by Rs. You know this. And same resistor you have to connect. These 2 are correct here. These 2 are equivalent circuits. And you should reconnect the load resistance. That's why I have given that. For ideal sources, it is a violation of KVL or KCL. That's why we cannot apply source transformation for a technique for the ideal sources. While coming to that, the above two circuits are equal with respect to performance wise, but not with respect to connections point of view. Connections point of view means what? Connections point of view ante ikkada voltage source undi, current source undi. This resistor, series resistor, here parallel resistor. These are not equal. While coming to that performance ante enti, whatever the output we are getting from this, the current, load current, here this load current, entire load current for these two circuits both are equal. Both are equal, right? This is about the some basics and power calculations also there. And while coming to that, ప్రీవియస్ ఇయర్ క్వశ్చన్ చూద్దామండి. ఇది సమ్మరీగా తీసుకోవచ్చు మనం బేసిక్ టర్మినాలజీకి. ఇప్పుడు యాక్చువల్లీ యువర్ ఇంటరాక్షన్ షుడ్ బి స్టూడెంట్ ఇంటరాక్షన్ ఐ హ్యావ్ గివెన్ నా. ఆ స్టూడెంట్ ఇంటరాక్షన్ ఇప్పుడు స్టార్ట్ అవుతుందన్నమాట. యూ నీడ్ టు బి ఆన్సర్ ద క్వశ్చన్స్. నౌ టెల్ మీ ద ఆన్సర్ ఫర్ దిస్ వన్. దిస్ వాజ్ గివెన్ ఇన్ AP GENCO 2012. Guys, heavy syllabus ఏం కాదు. Don't think like that. Some of the students are thinking that heavy syllabus. What is the answer for this one? The question is, in the circuits, the voltage across the 4 ohms resistor V can be expressed as, in terms of E and IR. Suppose if you take that V by 4 and this is I. What is the current here? I plus V by 4 into 6 plus V. KVL expression. Very simple. Now what we are getting, that current always from positive to negative. This is negative to positive, positive to negative, positive to negative. That means this voltage is equal to by KVL. Are you getting, guys? By KVL, I plus V by 4 into 6 plus V. V value తీసుకోవాలండి మనం. V value ఎట్లా తీసుకుంటాము? Look here, 6i, a simple calculation is there. 6 by 4 times of V plus V. ఇది 10 by 4 వస్తుంది ఇక్కడ, right? Are you getting that? 6i plus 10 by 4. 10V by 4. 10V by 4 means what? 24. Now 4E is equal to, what we are getting, that 24I plus 10V. Are you getting? Now V value, how much you are getting? That 0.4 plus 2 minus 2.4I. Very simple calculations here. Whatever the questions which we are identifying, that 0.4E minus 2.4I. Is it right? Are you getting? Is it okay? 0.4E minus 2.4I. Option C is the correct one. Right, very good. Somebody are given. Trinesh or Tritesh. He was given correct answer. Okay, got it, guys? Let us take the next example. Is it okay? This is very important here. This was given in NPTCL also. Some of the students, this is, you may think that a wire has resistance of 12 ohms. It is bent in the form of an equilateral triangle. Now tell me the answer for. What is the answer? Any one of you? A wire has a resistance of 12 ohms. It is bent in the form of an equilateral triangle. The effective resistance between any two corners of the triangle. What is the answer? Very good here. Raviteja, Sampath. suppose if you want to take these two, total is 12 here, 12 by 3, nothing but what here, 12 by 3, each side value how much here, 4 ohms, no? What we are getting? This is, it is bend in the form of 12 by 3 here, 4, 4, 4, very good. What we are getting that? Sometimes you may think that 12 plus 12 plus 12. That is not correct. Here 4, 4, 8. 8 parallel with what? 4. What we are getting that? By looking into these two terminals. You should look from any two terminals here or any side. 8 into 4 by 8 plus 4. 8 by 3. Option A is the correct one now? Yes or no? Getting? Right. This is very simple. Now let us take this one. This is a good one here. Tell me that an ideal ammeter is connected between the terminals A and B. The reading of the meter is, tell me this. Ideal ammeter internal resistance value how much? 0, no? Now once you are providing here short circuit path, this can be neglected, no? Once this can be neglected, under that instant I can say that these two are in parallel. These two are in parallel, 3. Nothing but here 1 ampere you are getting. No? 1 ampere you are getting means it will be divided into 2 equal half, 0.5. Option C is the correct one. Is it okay? Are you getting, guys? First, this resistance can be neglected since across short circuit any passive element can be neglected. Internal resistance of ideal ammeter is equal to 0. Resistor 0 means short circuit. Okay? Is it clear? Very good, very good. All are giving correct answer. I think now you are ready to fight. Okay. This is the some of the students, they are confusing here. The current in the 1 ohm resistor is, tell me guys. The current in the 1 ohm resistor is, tell me guys. You are thinking that the two sources are there, both are one. First of all, whenever two or more voltage sources are connected, first you need to see that whether the polarities as well as magnitude both are same or not. You may think that here two voltage sources are there, but both are same. Both are same means what? Only 1 volt is affecting, right? This equivalent circuit you can take it as a 1, then 1 by 1 which is equal to 1 ampere only. You may think that here some of the students are having a doubt usually, sir, two sources are there, why can't you take that superposition theorem? But here actually this is not two sources. The equivalent circuit can be replaced only like this, because only one source is affecting. According to the theoretically we can express like this, 1 ampere. Is it okay? Is it clear guys? Very good, very good. All are giving correct answer. But you should remember that these are not two sources. Only one source is affecting. Only one source is affecting. Even though if you take one more, 1 volt. Suppose if you take this in the place of 1 volt, 2 volt is there. What is the answer? Answer is not there. Because it is violation of KVL. Suppose if you take this one here, it is violation of KVL. Now what we are getting that? I can take it. Previously 1 minus 1 is equal to 0. Now 1 minus 2 is not equal to 0. Minus 1 is not equal to 0. It is violation of KVL. This circuit does not exist if it is 2 volts. Instead of 1 volt, 2 volts given. That is the answer, but option is not there. He will provide that circuit does not exist. Let me consider the next one. Right, this one here, this type of questions, see this one. TS SPDCL in 2015 is given. 4 parallel resistors connected in parallel with 5. 4 parallel resistors are connected in parallel with 5 resistors are connected in series. across that the DC supply 210 volts, right, 4 parallel circuit, you can do it here. 4 parallel circuit resistors are you can do it here fast. Why I am giving time means you can do it. A DC voltage source 210 volts and 5 amperes is there, or total how much? R equivalent value how much? R equivalent value is equal to R by 4 parallel with 4R na? Yes or no? Now what we are getting that R by 4 into 4R by R by 4 plus 4R. What we are getting this? 4 will be cancelled. Now 4R square, nothing but 4R by 16, 17R. Nothing but you need not take that R. Which is equal to what? Here V by I na? 210 by 5, which is equal to 42. Yes or no? Five series resistors here. Okay. 5 series resistors here. 5R, not 4R. Okay. 5 series resistors are there. What I can take it here? 5R by 21 na? Yes or no? 5R by 21. 5R by 21 is equal to this one. Now R value how much you are getting that? 42 into 21 by 25. This one also it is given na? Actually it is given 42 into 21 by 25. 10 into 21 by this is the A option is given 42 by 21 by 25 ohms. Actual answer is there, and this one also 21 by 25 is given. Option A is the correct one. These options are not correct. These type of questions you may get it here. This type of questions you may get it. 4 parallel resistors are connected in parallel with 5 series resistors are connected in parallel with. Suppose in series with means that is the different. Now answer is what? This one. For the answer is R equivalent is, or R value is equal to 42 into 21 by 25 ohms. This is the actual value here, R value. Is it okay? Any confusion here? Any confusion? Okay. Some of the students you are taking that D option. D option means you will get it. Suppose this combination is connected in series. Under that instant you will get D option. That is what here. What we are getting that 210 by V by I here. 210 by 5 is equal to R equivalent. Suppose if this 5 series resistors are connected in series with the parallel combination. Some of the students you may think like that here. Under that instant, nothing but what? The combination will be 1, 2, 3, 4, 5. ఈ 5 రెసిస్టర్లు 4 రెసిస్టర్స్ ప్యారలల్ కాంబినేషన్లో రెసిస్టర్స్ సిరీస్లో కనెక్ట్ చేస్తే నౌ ద ఆన్సర్ ఈజ్ 8 యూ విల్ గెట్ ఇట్. నౌ వాట్ ఈస్ దిస్? దిస్ ఈజ్ ఆర్ నథింగ్ బట్ వాట్? 5R ప్లస్ R by 4 ఈజ్ ఈక్వల్ టు 21R by 4 is equal to what? 42 na? Now this is 2 times na? Now R value is equal to 8 ohms you are getting. If this is the combination, you will get 8 ohms. But this is not the combination. 4 parallel resistors connected in parallel with the 5 series resistors. 4 parallel resistors are connected in parallel with the 5 series resistors. That's why this is the correct answer here. Actual options also, I think it was given like this. Okay? Is it clear? Very good, very good. This type of R equivalent values, మనం R equivalent లో perfect అనుకొని వెళ్తాము. You may get some confusion according to the given question. That's why you should be perfect these type of questions. ఇట్లాంటి క్వశ్చన్స్ని మనం ప్రాక్టీస్ చేయాలండి. చూడండి ఆన్సర్ 8 అని డీలో ఉంటే ఇఫ్ యూ థింక్ లైక్ దిస్ యూ ఆర్ గెటింగ్ ద డి ఆప్షన్. బట్ యాక్చువల్లీ క్వశ్చన్ వాజ్ గివెన్ లైక్ దిస్. ఓకే, నౌ టెల్ మీ దిస్, వాట్ ఈస్ ద విఏబి? This is the simple question here. Without putting pen, you are able to get it here. How you get it? Without putting pen. What is the answer? Tell me for this. Okay. It is correct. Okay, look here. How you have to do it? 2 into 8 by 2 plus. 2 plus 8 is 10. 2 into 8 is what? 16. 1.6. Na? You are getting that 1.6 here. 1.6 into 3. 4.8. 4.8 plus how much it is? 6. 4.8 here 4.8 plus 6. 10.8. 10.8 means what? Where we are getting the 10.8? Option C is the 10.8. C is the correct option. Is it right? Very simple here. This total is connected in series with this. How much it is? 1.6. Less than 2 na? Okay. Same current is passing through this. This is VAB is required. Now we need to get it this value here 6 volts and 1.6 ohm means here totally we are getting according to that 3 into 1.6 is 4.8 volts. Now finally by KVL VAB is equal to what? VAB is equal to 6 plus 4.8 which is 10.8. 36 is not correct, 27 is not correct, 8 by 3 is also 10.3 you will not get it, 54 by 5 is exactly 10.8 you are getting. Is it right? Is it clear? Lakshmi, I think you have done some wrong calculation. Let us check it that. How you have done, you need to check it. Okay? Shall we move the next question? Right. Tell me this. This is very simple here. Power dissipated in watts in the resistor R. Without putting pen. Nothing but what? Think without ink. Without putting pen. Think without ink. Directly you can do it. This is what? 6 amperes, 10 ohms. 10 amperes, 6 ohms. We don't need current here, we don't need power here, we don't need current here, we don't need power here. We want to get it that combination or the another resistor which is not associating with the current sources. So very simple. Here 60 volts, here 60 volts, both are opposing. How much this is? Oh, very good, very good. Veeraya, excellent. Here 60, here 60. What is that? Difference 0. That's why in this one power is 0 here. In this one power is existing, in this one power is also existing. Right? But resistance power is equal to 0 by STT, by source transformation technique. You can take it here. This is resistance. Resistor. This is the only single step here. Here 60 volts, here 60 volts. Here 6 ohms, here 10 ohms. Here R. Now current value how much? I is equal to what? 60 minus 60 by whatever it is here R equivalent. 0 amperes, then power is equal to 0 in this one. Right? But in this case, suppose if you want to get power in 10 ampere, 10 ohms resistor is existing. It is not 0. Because on the time we cannot do source transformation here. Here 0 current is passing through that, entire current is passing through this one. 60 into 10, I square into R, 360 watts here. Here also, 10 square into what? 6. 60 watts here we are getting that. That's why power is existing in 10 ohms, power is existing in 6 ohms because current is passing through that. Where the current is 0, only R resistor current is 0. In this current is 0, power is existing. In this current is 0, power is existing. Entire power, according to the power calculations, Telegen's theorem, the algebraic sum of all powers in any circuit is equal to 0. Okay? Shall we move the next example? Right. These type of questions you will get it here. TS NPDCL it was given. What is the value of I2 in the network shown below? This one also without calculations here. Tell me. Tell me, excellent question here. Without putting pen. Think without ink. Think without ink. This question, what is the value of I2? I am not getting correct answer. Any one of you? V1 value, how much here? Enta V1 value? 4 volts na? Appudu idi emoutundi? 10 kada? How the current direction? Current direction is opposite direction of the dependent source direction or not? It is not DR. It is C. Yes, yes. Koti, you are correct. Very good, Raviteja. Ramahi. Good, good, good. Here by KVL you can get it here. V1 is equal to 4 volts. Now this one is what? 40 amperes. Both are opposing. Then I2 is equal to what? Minus 40. Without putting pen you can get it here. Option C is the correct one. These are the some of the practice questions. This was given in 2018. Let us take the next one. All right. These are the some of the questions. Almost all are covered in this one. Shall we move the next chapter? Next chapter is somewhat all are feeling that is a very much difficult. You need not feel that as difficult. Let us take that the transient circuit analysis here. In this one, transient circuit analysis, how the questions are very simple. You need not bother about that. And you cannot expect that the gate questions you may get it. Don't expect like that. Right? Even though if you want to take the gate questions, go for only 1 mark questions here. Don't go for the deeply for complicated questions under gate examination, 2 marks questions, don't go for that. Try to solve the ESC questions. That is more than enough. Right? Under this one here, according to the tsgenco syllabus notification given, I have taken that DC and AC transient circuit analysis under that source-free circuits with source circuit, transient circuit analysis using Laplace transform analysis and summary of that one. Now under this, first I would like to take the summary, then after that some of the important formulas I will provide, then after that some questions, 1 or 2 questions or 3 questions we will take it. Is it okay, guys? Shall I move? Okay, very good. Very good. Now here, transients in the system mainly because of the energy storage elements which are either inductor or capacitor or both. The network is experienced with the sudden changes. Both should happen here. This has to happen and this has to happen. Otherwise, no transients. No transients. Inductor can never allow the sudden changes in the energy. Nothing but current does not change instantaneously. Voltage does not change instantaneously. Our resistor allows here. Resistor T equal to 0 minus లో ఒకటి ఉండొచ్చు, T equal to 0 plus లో ఒకటి ఉండొచ్చు. But it is not possible for inductor current and capacitor voltage. Because energy is in the form of current, psi is directly proportional to I. Here energy charge is directly proportional to V. Alright, transient regarded as the argument between the source and source to the load. Right, the state variable in the network changing from the previous steady state to next steady state. Previous steady state to next steady state. That's important. And These are the very important for you, and this table is very important for you. Once if you are able to fill this table, then definitely you will get it. At t equal, for t greater than 0, resistor act as resistor only here. Okay? And at t equal to 0 plus, it is independent of time. That's why it is always act as resistor. It always act as resistor. And while coming to that inductor, for t greater than 0, inductor act as inductor only. There is no change in this one. And while coming to that at t equal to 0 plus, inductor act as open circuit, you know that. Because energy in the form of current is 0. Initial current is 0. Or initial current is something, 2 amperes into 2 minus 2, you will get it 0. The exact operation at t equal to 0 plus means what? 0 plus means just after switching action. T equal to 0 plus. That everything we will discuss in our class here. T equal to 0 plus. What is t equal to 0 minus? That is the t equal to 0 minus means before switching action, just before switching action, steady state position. Right? Everything you will get it. Once you take that the enrollment in ACE Engineering Academy, everything you will get it here. We are ready to provide. And while you are taking that under steady state condition, t equal to infinity means what? Steady state position. This under this inductor act as a short circuit. Okay? Now, if you take that inductor here after t equal to 0 with, if it is having with initial current means what? A parallel current source. This is very simple, and you will get it. Parallel current source as usual, but here parallel current source ikkada avasaram ledandi. You need not take it, including that short circuit ante which offers, some of the textbooks are taken as a current source parallelly. Avasaram ledandi. Short circuit ante including only short circuit ga manam we can replace that as short circuit under steady state condition. While coming to that capacitor enti? Capacitor, this is for t greater than 0, C farads. Now at t equal to 0 plus, it is act as a short circuit without energy. Without energy means what? Initial value of the capacitor is equal to 0. At t equal to infinity, once if it is charging, then it offers maximum energy. Maximum energy means what? Maximum energy means you will get open circuit. Now suppose if you are taking that initial energy is existing anukondi. Initial energy exist avutunte series lo connect chestam anamata. Appudu total current, total voltage emotundi? This voltage plus initial voltage. Now here at t equal to 0 plus, while coming to that, it is short circuit with series voltage source. ఇక్కడ ఓపెన్ సర్క్యూట్ ఏంటంటే ఇంక్లూడింగ్ ఇనిషియల్ వోల్టేజ్ని రీడ్ చేస్తుందండి. దిస్ విల్ రీడ్ ఇంక్లూడింగ్ ఇనిషియల్ వోల్టేజ్. దిస్ టేబుల్ ఈజ్ వెరీ ఇంపార్టెంట్ ఫర్ యూ హియర్. వన్స్ ఇఫ్ యూ హ్యావ్ ద టేబుల్, దెన్ డెఫినెట్లీ యూ కెన్ టేక్. అండ్ ఐ యామ్ ప్రొవైడింగ్, ఏదైనా ట్రాన్సియెంట్ సర్క్యూట్ ప్రాబ్లం వచ్చినప్పుడు మనం 3 కండిషన్స్ని వెరిఫై చేయాలండి. వన్స్ యూ కన్ఫర్మ్ ద 3 కండిషన్స్, దెన్ యూ కెన్ ఫార్వర్డ్ ద అనాలిసిస్ ఆఫ్ ద ట్రాన్సియెంట్ సర్క్యూట్స్. ట్రాన్సియెంట్ అనాలిసిస్ని మనం కంటిన్యూ చేయొచ్చు అనమాట. ఎప్పుడు ఈ 3 కండిషన్స్ సాటిస్ఫై అయితే. వాట్ ఆర్ ద 3 కండిషన్స్? See this one. Conditions to be verified for transient circuit analysis. Network existing sudden changes from the excitation or not. Usually ఎట్లా ఉంటుంది sudden changes in the form of switching action. ఒకసారి స్విచ్చింగ్ యాక్షన్ ఇవ్వడండి, దెన్ వాట్ వీ నీడ్ టు డూ దాట్? వీ షుడ్ వెరిఫై ద ఎగ్జైటేషన్. సమ్టైమ్స్ స్టెప్ ఎగ్జైటేషన్ ఇస్తాడు, సమ్టైమ్స్ ఇంపల్స్ ఎగ్జైటేషన్, సమ్టైమ్స్ హియర్ ramp excitation. When these type of functions are provided under that instant also, when the sudden changes are existing at t equal to 0 or at t equal to a finite time, after that you will provide the, or you will get from that network after sudden changes the transients anamata. Andukani first manam check cheyalsindi entidi, whether sudden changes are provided from the excitation or not. Usually switching action untadi, right? Next thing is the network contains energy storage elements or not. ఈవెన్ ద సడన్ చేంజ్ ప్రొవైడ్ చేసినా కూడా ఎనర్జీ స్టోరేజ్ ఎలిమెంట్ లేదనుకో, ఓన్లీ రెసిస్టర్స్ ఉన్నాయి అనుకో, దెర్ ఆర్ నో ట్రాన్సియెంట్స్. వై? బికాజ్ మెయిన్లీ ట్రాన్సియెంట్స్ డ్యూ టు ఆన్ ఇండక్టర్ అండ్ కెపాసిటర్స్ ఓన్లీ, రైట్? నెక్స్ట్ ఏంటి? థర్డ్ థింగ్ ఏంటి? ఇవి 2 సాటిస్ఫై అని అనుకోండి. థర్డ్ థింగ్ వీ నీడ్ టు వెరిఫై హియర్ అకార్డింగ్ టు ద స్విచ్చింగ్ యాక్షన్, ఆ ఇండక్టర్ కానీ కెపాసిటర్ కానీ వెదర్ ద ఇనిషియల్ వాల్యూస్ ఆర్ ప్రొవైడెడ్ ఆర్ నాట్. ఇవి ఇనిషియల్ వాల్యూస్ ఆర్ గివెన్, ఈ థర్డ్ పాయింట్ అవసరం లేదండి. ఇనిషియల్ వాల్యూస్ ఇవ్వలేదనుకో ఈ థర్డ్ పాయింట్ అవసరం లేదు. ఇచ్చాడంటే ఇవ్వకపోతే then we need to verify that if the initial values L and C given or not. If it is given, consider those values for circuit analysis after t equal to 0. Suppose if it is not given, verify the given circuit whether they are existing or not by taking the switching action before t equal to 0. Before t equal to 0 switching action తీసుకొని ఇండక్టర్ కానీ కెపాసిటర్ కానీ both are affecting with the source తీసుకొని if they are affecting then we should go for a t equal to 0 minus condition అనమాట. అది before t equal to or before switching action steady state position. Everything these are the three conditions you need to be check it while you are while you are continuing the transient circuit analysis. Okay. Now the source free circuit లో RL source free circuit లో మీకు IL of t ఉందనుకోండి. Once you are having that IL of t is equal to I naught into e to the power minus t by tau amperes for t greater than or equal to 0, where tau is equal to L by R or L equivalent by R equivalent seconds అండి. ఇది సోర్స్ ఫ్రీ సర్క్యూట్. సోర్స్ ఫ్రీ సర్క్యూట్ అంటే ఏమి ఫిజికల్ సోర్స్ ఉండదండి. ఇంటర్నల్గా this is you have this one, this is the current which we are getting, that IL of t. This is source. There is no physical source, but inductor have internal energy. RC కూడా ఎనర్జీ ఏంటిది? V of t. సేమ్ ఎక్స్ప్రెషన్ అండి. V of t is equal to V naught into e to the power minus t by tau volts, where t greater than or equal to 0. Tau is equal to RC seconds or R equivalent into C equivalent. Okay. ఇక్కడ కూడా అంతే. దెన్ వన్స్ యూ టేక్ దట్ వోల్టేజ్ ఈజ్ సేమ్గా తీసుకుంటాం. ఇది యు నో దట్. బట్ ఇనిషియల్ వోల్టేజ్ ఇక్కడ ఉంటుందండి. వితౌట్ ఇనిషియల్ వోల్టేజ్, సపోజ్ ఇనిషియల్ వోల్టేజ్ దీనికి, ఇనిషియల్ కరెంట్ దీనికి లేదనుకోండి, దట్ సర్క్యూట్ ఈజ్ నథింగ్ బట్ వాట్ సర్క్యూట్? డెడ్ సర్క్యూట్, రైట్? నా విత్ సోర్స్ సర్క్యూట్ తీసుకున్నాం అనుకోండి, యూ హ్యావ్ ఎ యూనివర్సల్ ఫార్ములా యార్. ఇది గుర్తుపెట్టుకోండి అండి. IL of t ఈజ్ ఈక్వల్ టు IL of infinity ప్లస్ IL of 0 మైనస్ IL of infinity ఇంటూ e to the power minus t by tau amperes, which is valid for t greater than or equal to 0. ఇది సోర్స్ ఫ్రీ సర్క్యూట్స్ కానీ విత్ సోర్స్ సర్క్యూట్ కానీ ఇన్ జనరల్ యూనివర్సల్ ఫార్ములా అండి. IL of infinity ఈజ్ ద ఫైనల్ వాల్యూ. ఆర్ యు గెటింగ్? IL of 0 is initial value. Time constant ante already we have taken that, the same time constant. This we will consider for RL with source circuit. Source free circuit got is valid. Ikkadenti VC of t we can take it for VC of infinity plus VC of 0 minus VC of infinity. How to find out the initial value, final value? You know that here. Volts for t greater than or equal to 0. Now VC of infinity is final value, VC of 0 is initial value. You know this. And time constant also, you know this. Time constant eppudaina manam, this is valid for t greater than 0 kada. 3 greater than 0 తీసుకొని, depending upon that switching action, we need to verify that what is the R equivalent, what is the C equivalent, what is the value of R, what is the value of L or C. Like that you can take it. Okay. Now let us take that second order circuits వచ్చినాయి అనుకోండి. ఈ సెకండ్ ఆర్డర్ సర్క్యూట్స్ వచ్చినప్పుడు then better to take that here what? Laplace transform analysis circuit అండి. ఈ Laplace transform circuit analysis ని చేస్తారనమాట. If the order is greater than 2, when the Laplace transformation is used in transients, when we have to use that, usually order is greater than that. While estimating the time constant of the circuit is very much difficult, that's why we should go for that. It is the non-canonical formula. Non-canonical formula ఉన్నప్పుడు యూజ్ చేస్తారు. అండ్ non-ideal inputs అండి. Non-ideal inputs means what? Like impulse, step, ramp, parabolic, exponential. ఇట్లాంటివి వచ్చినప్పుడు normal time domain analysis, it will take so much time. It will be the conventional process. But you have to answer within 1 minute. Then under that instant, if you want to get the correct answer within 1 minute, definitely we should take the help of the Laplace transformation. అందుకని Laplace transformation higher order functions కి మనకి within stipulated time, or if you want to answer that the correct time, then definitely we should take the help of the Laplace transformation. Okay. Example చూద్దామండి. Previous year questions ని PSCs లో ఇచ్చినవి చూడండి. Can you tell me the answer? It's very simple here. The question is, it was given EPDCL. A circuit shown in the figure is in steady state when the switch is closed at t equal to 0, assuming that the inductance is ideal. The current through an inductor at t equal to 0 plus is. See this. Oh, yes. Yes, Lakshmi, that is correct. 25, not 5. or 5? I will see. It might be 5 or 25. Tell me that assuming that before t equal to 0, ఇక్కడ 3 conditions మనం అప్లై చేద్దామండి. ఏ 3 conditions ని? See this. Right. Network is sudden changes are not. Next ఏమో energy storage element. Next ఏమో initial value. Let me define that these 3 conditions. Right. See this. Now sudden changes are provided from the excitation. Yes, switching action is there. This is the first one here. Second thing is what? What we can take it the second thing? Second thing is I can say that energy storage element is there. Energy storage element initial value ఇచ్చాడా? ఇవ్వలేదు. That means what? We should go for. We cannot take 0 here. We need to be verify that whether it is existing or not. Then how you define that before t equal to 0? Before t equal to 0 switch position ఏముంటాయి? Switch is going to be, switch is opened. Whether it is opened, whenever if it is opened, before at t equal to 0 switch is closed. That means before t equal to 0 it is opened. Once it is opened, is it affecting with the 10 volt source? Yes, it is affecting. Then under that instant, what we have to take it? Before t equal to 0, once you see this one, this is very important, the diagram. Usually we will consider that at t equal to 0 minus, at t equal to 0 plus, and at t equal to infinity. This is what exactly switching action at t equal to 0. T equal to 0 means 0 minus means just before switching action, just after switching action. This is the starting point of transient, and this is the ending point. Nothing but what? Steady state. 2 steady states ఉంటాయండి usually. 2 steady states ఉంటాయి. When before t equal to 0, if it is affecting with the source. Otherwise, there is no source. If it is affecting, then initial value is equal to 0. It will start from 0. If it is affecting, then we have to take that. How you consider that? Under steady state, inductor act as what? Short circuit. By making this as a short circuit, you have to take it here. This is what? For t less than 0, switch is open. Are you getting? Now here how much current is passing through that? 1 ampere. No? Now IL of 0 minus is equal to 1 ampere, which is same as IL of 0 plus here. Why? Because in an inductor, current does not change instantaneously. Current does not change instantaneously. This value is nothing but what value? Initial value. That's why at t equal to 0 plus, what is the inductor current? Inductor current at t equal to 0 plus, same current పోతుందండి. How much it is? D is the correct option. Some of you are given the correct answer. Yes, exactly. Okay. Right. ఈ క్వశ్చన్ చెప్పండి అండి. సోర్స్ ఫ్రీ సర్క్యూట్ క్వశ్చన్ 2019లో ఇచ్చాడు SPDCLలో. టైం కాన్స్టెంట్ ఎంత దీనికి? హియర్ ఆల్సో 3 కండిషన్స్ అప్లై చేయాలండి. యూ షుడ్ అప్లై ద 3 కండిషన్స్. ఫస్ట్ వన్ ఈజ్ స్విచింగ్ యాక్షన్ ఈజ్ అవైలబుల్ ఆర్ నాట్, ఆర్ గివెన్ ఆర్ నాట్? ఎస్. ఎనర్జీ స్టోరేజ్ ఎలిమెంట్ ఈజ్ గివెన్ ఆర్ నాట్? ఎస్. Third thing is what? Initial value of this one is given? Not given. Once you see the question in the circuit shown in figure, the switch on the position 1 for a long time, for a long enough to establish a steady state, and switched to the position 2 at t equal to 0, the current I for t greater than 0. Long time ఇక్కడ ఉందండి, అంటే before t equal to 0. At t equal to 0, it is changed to this one. అంటే లాంగ్ పొజిషన్లో ఉంది. నా మై ఫస్ట్ కండిషన్ ఈజ్ సాటిస్ఫైడ్, సెకండ్ కండిషన్ ఈజ్ సాటిస్ఫైడ్, థర్డ్ కండిషన్ ఇనిషియల్ వాల్యూ నాట్ గివెన్. దట్స్ వై వీ నీడ్ టు వెరిఫై బిఫోర్ t equal to 0 స్విచ్ పొజిషన్ at 1. Nothing but this inductor is affecting with the 50 volt source. That means it is existing initial value. Now once you take that initial value, what you have to take it here? At t equal to 0 minus, make it that as a short circuit. Once you make the short circuit here, how much current is passing through that? 5 amperes. No? Now IL of 0 minus value how much? 50 by 10. Yes or no? 5 amperes. It is same as what? IL of 0 plus, since current does not change instantaneously for an inductor. Now after t equal to 0, switch position emundi ikkada undi. Then is it inductor is affecting any source? No, it is not affecting. But is it having initial value? Yes, it is having initial value. That means under that instant after t equal to 0, this entire network is to be converted as a source free circuit. Na? Now for source free circuit lo manam already we have taken. Na? What is the formula for IL of t? Inductor current adigadu, I value adigadu. This I value is asked. That means inductor current. We have a direct formula. What was the direct formula? IL of t is equal to I naught into e to the power minus t by tau. I naught value how much you got it? 5 into e to the power t by tau. Tau value how much? L by R. L by R means what? Tau is equal to L by R 0.2 by 10. Nothing but 2 by 100. 1 by 50 seconds. Yes or no? Now this we are getting 1 by 50 means what? 50t now. 5 into e to the power minus 50t. Option C is the correct option. Yes or no? Very good. Ravi Teja, you have given correct answer. Right. Umesh, have you got the concept? Right. Shall I move the next? These are the three conditions here. Once you remember the three conditions, definitely you can answer the question. Now see this one. Refer to the circuit shown in figure. If Vs and Is are Laplace transformation, if V of t, I of t, then I of s by V of s here. Actually, this is second order circuit, no doubt in that. I of s by V of s ante enti? What it is? I of s by V of s is what? V of s by I of s ante impedance. This is the admittance. Nothing but what? 1 by Z of s. Nothing but what? Y of s. Series kabatti here, once you take that Laplace, this will be here. Are you getting, guys? Now, this is Laplace lo convert cheste. This question, entire circuit, if we convert into Laplace, what we are getting that here, V of t is going to be V of s, I of t is going to be I of s, inductor is S ohms. Anni ohms lo kochesteyandi 1 by S. Now Z of s kanukochu directly. Z of s is what? V of s by I of s. Now while finding that Z of s is equal to what? S plus 1 plus 1 by s. Nothing but what? S square plus s by s. But Y of s. Y of s is what? Inverse of Z of s. Nothing but what? S by s square plus s plus 1. Which is the correct option? Very good, very good. All are given correct answer. This second order circuit kochinapudu, better to use the Laplace. You can get the answer within the time. That is advantage. Okay? Shall I move? This is the good question here. Without putting pen, you can tell me the answer without putting pen. Guys, let us. Any one of you. Any one of you. The question is, for the network shown below, the switch is closed at t equal to 0. What is the value of dV by dt at t equal to 0 plus? Before t equal to 0, switch is opened here. Switch open ayindi kabatti, again three conditions. What are the three conditions? We need to take it. First one is switching action. Second one is energy storage element. Third one is initial value. Initial value is not given. If initial value is not given, we should go for that before t equal to 0. Before t equal to 0, switch position etlundi? Open lo undi. Is it inductor or capacitors are affecting with the source? No. That's why initial values are what? 0. Once initial values are 0, then take a t equal to 0 plus, because we need the answer at t equal to 0 plus. And enti here dV of 0 plus by dt kavala. Where? Across resistor or inductor or capacitor. Rate of change of voltage, if you want to get it across resistor or capacitor. Capacitor దగ్గర మనం define చేయొచ్చండి. How can you define that? Because capacitor opposes rate of change of current, rate of change of voltage. A rate of change of voltage toti we are able to define the current. where you have to define the current at t equal to 0 plus. What is the behavior of the capacitor at t equal to 0 plus? ఒక్కసారి మనం టేబుల్ చూస్తే, once you see the table, then definitely you will know that at t equal to 0, capacitor act as what? Short circuit. Once the capacitor act as short circuit, definitely here short circuit path current define చేయొచ్చు కదా. See this. ఒక్కసారి చూడండి, డైరెక్ట్గా you are able to say that without putting pen. No initial values here. Now the entire network at t equal to 0, just imagine the network. Switch position close లో ఉందండి. Then resistor act as resistor. Inductor act as open circuit. Capacitor act as short circuit. అంటే ఇక్కడ open circuit, short circuit, resistor. Nothing but what? Across short circuit, any passive element can be neglected. Na? అంటే IC of 0 plus, we are able to define that IC of 0 plus. IC of 0 plus ని define చేయొచ్చా? Switch closed కదా. 10 amperes. Very good. Once you will get the IC of 0 plus, IC of 0 plus means what? Here IC of 0 plus is equal to C into dVC of 0 plus by dt. This formula, if you know that, you will get it. And dVC of 0 plus by dt enti IC of 0 plus by C. And 10 by C. C value how much? 0.5. 10 by 0.5 how much? 10 by 0.5 micro. Nothing but what we are getting that 10 by 0.5 means what? 100 by 5. Is it right? 100 by 5 means what? 20. Yes or no? 20 into micro. Nothing but what? 20 into 10 power 6 you will get it. Because 1 by micro is 10 power 6. Now 2 into 10 power 7. Where it is? Option D. Very good. It was given that. Very simple. Make the short circuit, get the IC of 0 plus value. ఇది ఓపెన్ సర్క్యూట్ చేసి దీన్ని షార్ట్ సర్క్యూట్ చేస్తే స్విచ్ ఈజ్ క్లోజ్ అయితే ఎంటైర్ కరెంట్ ఈజ్ పాసింగ్ త్రూ దిస్ వన్. నౌ the detailed discussion, suppose if you take it here 10 amperes, here 0.5 micro, dVC of 0 plus by dt. Now dVC of 0 plus by dt is equal to what? 10 by 0.5 micro అంటే 10 power minus 6 అంటే 2 into 10 power 7 volts per second. This is the direct answer. How it is? Very simple. First 3 conditions, if you know that, how to apply for any type of transient circuit, you can take it. Right? This is the way how the questions you will get it. Okay? Are you comfortable? It's very simple here. You can easily get it. These type of simple tricks or simple shortcut methods, you need to be habituated. This one also. This is the previous transco as well as gate examination question here. A series RC circuit, RL circuit is excited at t equal to 0 by closing a switch as shown in figure, assuming 0 initial conditions, the value of d square I by dt square at t equal to 0 plus. Tell me this. It's very simple here. Now switch is closed. Take this one. Now you will get it. This is what? Initial current is equal to 0. Initial value em ledhu kada ikkada. Before t equal to 0, switch is opened, there is no initial value. Then directly I can take it here. I of t value how much? I of t is equal to, you will get it V by R into 1 minus standard formula andi. T by tau. Where tau is equal to what? L by R. Are you getting? But d square I of t by dt square adugutunnadandi. Now once you differentiate that, di of t by dt, what we are getting? V by R into 0 minus e power minus t by tau into minus 1 by tau, where tau is equal to L by R. This RR will be cancelled. What we are getting? Minus into minus is what? Plus we are getting. Now V by L into e to the power minus t by tau. Very simple. Now again then differentiate cheyalandi. If you differentiate the d square I of t by dt square, but he didn't ask that at t equal to 0 plus. Right, at t equal to 0 plus, no doubt in that. But differentiation, double differentiation is compulsory, we should go for the equation. Otherwise, at t equal to 0 plus, if you want to take it, I of 0 is fixed. If you differentiate that, you will get 0. If you differentiate that, you will get 0. But that is not the correct answer. Because inductor current, rate of change of current is existing. With that, we can define voltage at t equal to 0 plus. At t equal to 0 plus, inductor etla act chestundi? Open circuit. Open circuit voltage can be defined? Yes, we can define. Right? With that di by dt you can take it, because across inductor V is equal to what? L into di by dt. Now from the d square of t by dt square, if we do it, what we are getting, that e power minus t into minus 1 by tau andi. What we are getting, that L by R. And final game was the minus VR by L square e power minus t by tau. This 0 by e power 0 value how much? 1 minus VR by L square. That option is there? Yes, RV by minus VR by L square. This is the correct answer. Are you getting? Previous gate question as well as this was given in 19 AP transco ఇచ్చాడండి. ఇది ఏపీలో ట్రాన్స్కోకి సిలబస్ సేమ్ గేట్ సిలబస్ ఇచ్చాడు, అందుకని క్వశ్చన్స్ అన్ని రిలేటెడ్ విత్ ద గేట్ క్వశ్చన్స్ ఇచ్చేసాడు అనమాట. రైట్, నెక్స్ట్ వన్. రైట్, దిస్ guys, our time is going to be completed. That's why you can do it directly. I will give this one. You can answer this one. R by 2L. RLC series circuit, na? Whether it is 1 by root LC. If it is greater than, overdamped. Less than, underdamped. You get it here, less than, underdamped. Equal to, critically damped. Is 0. 0 రాదులే, already R existing. Right? దాన్ని బట్టి మనం డిసైడ్ చేయొచ్చు. యూ కెన్ డూ ఇట్ దట్, యూ కెన్ రైట్ డౌన్. నా నెక్స్ట్, దిస్ ఈజ్ వెరీ ఇంపార్టెంట్, మోర్ వెయిటేజ్ అండి ఇది. ఏది? ఏసీ సర్క్యూట్ అనాలిసిస్. ద ఏసీ సర్క్యూట్ అనాలిసిస్, ఇట్ ఈస్ అ మోస్ట్ ఇంపార్టెంట్, మోర్ నెంబర్ ఆఫ్ క్వశ్చన్స్. మినిమం 4 క్వశ్చన్స్ వస్తాయండి దీంట్లో. ట్రాన్స్జెంట్స్లో 1 or 2 క్వశ్చన్స్ వస్తాయి, దీంట్లో 4 క్వశ్చన్స్ కంపల్సరీ. 3 to 4 క్వశ్చన్స్ లేండి. 3 మినిమం వస్తాయి, 3 to 4 100% విల్ గెట్ ఇట్. అంటే ఇంక్లూడింగ్ మ్యాగ్నెటిక్ సర్క్యూట్స్ని కూడా ఇంక్లూడ్ చేస్తే 3 to 4 క్వశ్చన్స్ వస్తాయి. ఓకే, నౌ సిలబస్, ఇంట్రడక్షన్ ఆఫ్ ద ఏసీ సర్క్యూట్ అనాలిసిస్, సైనుసాయిడల్ స్టడీ స్టేట్ అనాలిసిస్ యూజింగ్ ఫేజర్ అప్రోచ్, ఆర్ఎంఎస్ వాల్యూ, యావరేజ్ వాల్యూ, ఫార్మ్ ఫ్యాక్టర్, పీక్ ఫ్యాక్టర్, ఆర్ఎల్, ఆర్సీ. ఈ సిలబస్ని నేను ఎట్లా ప్రిపేర్ చేశాను అంటే, దాంట్లో ఓన్లీ మెయిన్ హెడ్డింగ్స్ ఇచ్చాడండి. బట్ అకార్డింగ్ టు ద క్వశ్చన్ విచ్ ఆర్ గివెన్ ఇన్ ద ప్రీవియస్ ఎగ్జామినేషన్స్, బేస్డ్ ఆన్ దట్ ఐ హ్యావ్ ప్రిపేర్డ్ దిస్. ప్లీజ్ కీప్ దిస్ ఇన్ యువర్ మైండ్. అంటే సార్ ఇది మొత్తం ఇవ్వలేదు కదా దాంట్లో అంటారు, బట్ క్వశ్చన్స్ వీటి మీదనే ఇస్తున్నాడు. ఓన్లీ ఒక మెయిన్ హెడ్డింగ్ ఇస్తాడంటే దాని కింద ఉన్నాయన్నీ మనం చదువుకోవాలన్నమాట. బేస్డ్ ఆన్ దట్ ఐ హ్యావ్ ప్రిపేర్డ్ దీస్ సబ్ హెడ్డింగ్స్ ఆర్ ద కాన్సెప్ట్స్ ఆర్ టాపిక్స్ విచ్ ఆర్ ఎగ్జిస్టింగ్ అండర్ దిస్ చాప్టర్. ఓకే, నా సమ్మరీ తీసుకున్నాం అనుకోండి. హియర్ V of t is equal to Vm sin omega t plus phi cos omega, both are sinusoidal. ఎప్పుడైనా మనము సర్క్యూట్ అనాలిసిస్లో తీసుకుంటే, వన్స్ యూ టేక్ ద సర్క్యూట్ అనాలిసిస్, అండర్ సర్క్యూట్ అనాలిసిస్ వీ షుడ్ కన్సిడర్ దట్ ఆర్ఎంఎస్ వాల్యూస్. ఇక్కడ యూజువల్గా మీ కన్ఫ్యూజన్ ఎట్లుంటుంది అంటేనండి, హియర్ ఈ విల్ ప్రొవైడ్ దట్ ఏసీ సోర్స్ 50 at an angle 0 degrees. దట్ మీన్స్ దిస్ ఈజ్ వాట్ ఆర్ఎంఎస్ వాల్యూ. రిమెంబర్ దట్. ఒక ఈక్వేషన్లో ఇచ్చాడు అనుకోండి 50 sin omega t plus 10 degrees అని ఇచ్చాడు అనుకోండి. వన్స్ ఇఫ్ ఇట్ ఈస్ గివెన్ లైక్ దట్, దిస్ ఈస్ ద మ్యాక్సిమం వాల్యూ. రిమెంబర్ దట్, రైట్? అండ్ సమ్ టైమ్స్ we provide that here 50, here 10 volts or 50 volts అని ఇచ్చాడు అనుకోండి. వన్స్ ఇఫ్ ఇట్ ఈస్ గివెన్ లైక్ దిస్, యూ షుడ్ కన్సిడర్ దిస్ యాజ్ RMS వాల్యూ. Directly 100 volts applied. How much source? We are getting the 230 volts. 230 volts is what? It is related with what? It is related with RMS only. That's why polar form RMS value, these are the sum of the points, average value, RMS values, AC analog meters. Again you will get in the measurements this parts, rectifier type, actual value, average value into form factor, and multiple sources తోటి చేస్తే, then if it is given when the signal is operating with the multiple frequencies, we can define the RMS value under root V0 square plus 1 by 2 times of V1 square, V2 square, V3 square, like that. These two values are same. If these n omega t different phasors ఇచ్చాడు అనుకోండి, then you should convert into polar form. This is the way how you have to take it. This entire expression we should write like this in polar form, right? Remember that is very important. Right, these are the some of the important points I have provided for pure elements: pure resistor, voltage and current behavior, phase angle, impedance, power factor. And while coming to that series circuit, observations here, these are the some of the observations I can take it. for series RL circuit, series RC circuit, RLC series circuit. This is not correct. VL minus VC whole square, under root is there here. For each one, under root is there. For each one, under root is there. R minus JXC, R plus J into XL minus XC, everything. You can take it. This, remember that, VR by V for all the times, power factor. Okay? For parallel circuit also I have provided. For parallel circuit also in the similar way we can take it. Here also under root is there. Under root is there. Under root is there. Okay? Here IR by I, power factor value on matter. Now power, instantaneous power, power factor, power triangle. Output power eppudu resistor దగ్గర ఉంటుందండి. Always the output power can be considered as the real power. This real power is also called what? Average power, real power, output power, power dissipated by the circuit, true power. Everything is nothing but what? Power due to one the resistance only, or multiple resistors are present in the network. Then we will consider that effective resistance power is nothing but the output power, wherever you are considering that. The apparent power S is equal to P plus JQ, absorbing, it is generating. Negative power ante capacitor power untadi, capacitor power ante it is generating. Generating means it is storing, which can be reutilized. Right? Now I will coming to that resonance end. Once you consider this is the resonance part, resonance only, the definition resonance can be done in 4 ways. Number 1 is resistive network, and phase angle, unity power factor, VI cos phi, classification of resonance, series resonance and parallel resonance. In parallel 3 types are there, RLC, RLC and RL and RC. Then this part is nothing but what? Tank circuit, I think you know that. And series resonance, the points which we need to remember under series resonance is this, I maximum. Under series resonance impedance is minimum, so current is maximum. That's why these are the acceptor circuits. Series resonance, the total voltage appears across the resistor only, hence it is called voltage amplification circuit. And the applications you can take it, design of the receivers, antennas in communication engineering, here we are considering that. Okay? Like that the parallel also here we are considering that. Net admittance is minimum, so current also minimum here. That's why current is minimum resistor circuits. Parallel circuits also, parallel resonance also resistor circuits untarandi. That's why anti-resonance. This resonance is also called what? Anti-resonance. Parallel resonance is called anti-resonance. Right? Current amplification. Current is going to be, hence it is current amplification. Total current passing through the resistor only at resonance దగ్గర. And this phenomena induction heating here. And RF amplifiers, both RL and RC circuits are using the tuning the filter circuits here. Low pass, high pass, band stop filters. Anyway, that we will discuss. And this one tank circuit here. Tank circuit, you know that a coil is connected with the ideal capacitor. Then that is nothing but the tank circuit. For this one, RL and C, ideal tank circuit ante LC and you know that this one is ideal tank circuit. For this one you are getting the dynamic impedance and no student. Sometimes you may ask the dynamic impedance. What is the dynamic impedance? The impedance offered by the network to the source under resonance condition, which is purely resistive in nature. Now for RLC series circuit ki dynamic impedance anta R. For RLC parallel circuit ki R ohms. For tank circuit ki L by RC, that you know that. And for ideal tank circuit ki infinite vastudandi. This you remember. Impedance infinite ante open circuit. Because resistance value infinity. Then that's why this is the open circuit. Okay? Magnetic circuits lo here analog concept of self inductance, mutual inductance, dot convention, summary of the magnetic circuits and previous questions keldamandi. Okay? Time is very less, that's why you can understand. And questions are important. These are important here. This is the important role or important time in this session. Solving the previous examinations. In a series RL circuit, the voltage across the resistance is 440 volts. Voltage across the inductance is 40 volts. And the total voltage will be how much? It is not 18. Here this is AC. AC means what? Definitely we should go for what? AC means here I can take it. V is equal to under root. Tell me that. VR square plus VL square na? Series RL circuit lo. 40 root 2. 55.6. How much it is? 56.56 na? Yes or no? RC series circuit andi. Are you getting this? Yes or no? Very good. It's a very simple question. Let me consider the next one. Q factor ichadandi and source voltage given. An RLC series circuit, resonant circuit, Q is 15 and source voltage 50 volts. The voltage across the capacitor at resonance. Voltage across the capacitor. Q factor for RLC series circuit is also called what? Voltage magnification factor. Na? That's why Q factor we can take it here VL by. What exactly we can take it, how you define that? Q factor is equal to XL by R here or XC by R. Multiply, current multiply cheste VL by VR vastadi. Or otherwise VC by VR. Directly and 15 ichesadu ikkada 50 ichesadu. Now VC is what? Q into VR. What I can take it? 50 into 15. 750. Option A is the correct one. Yes or no? Getting? Next. This you can take it here. V and IR given by the power dissipated. Power dissipated into EV, M values, maximum values. Power enti VI cos phi. Hundred by root 2. 100 by root 2. ఇవి రెండు సైన్లో ఉండే చూసుకోవాలండి ఫస్ట్ యూ షుడ్ వెరిఫై దట్ వెదర్ దే ఆర్ ఇన్ సైన్. పై బై 3 అంటే ఏంటి 60 degrees. కాస్ 60 అంటే ఎంత 1/2. 1/2 మీన్స్ వాట్ ఇయర్ 10,000 by 4. నథింగ్ బట్ వాట్ 2,500. 1000 by 4 అంటే 250. 10,000 by 4 అంటే 2,500. ఇస్ ఇట్ ఓకే? ఆప్షన్ సి. ఇది 0 degreesలో ఉంది కాబట్టి డైరెక్ట్లీ యూ కెన్ టేక్ ఇట్. ఓకే రైట్. DC voltage RLC series circuit దగ్గర అప్లై చేస్తే DC voltage డ్రాప్ ఎంటైర్లీ అక్రాస్ వాట్? వేర్ ఇట్ ఈస్ ఎగ్జిస్టింగ్ అక్రాస్ DC voltageకి కెపాసిటర్ ఓపెన్ సర్క్యూట్, ఇండక్టర్ షార్ట్ సర్క్యూట్న అక్రాస్ కెపాసిటరే ఉంటుంది కదా. ఆప్షన్ సీనా? వెరీ గుడ్. For RLC series circuit, the power factor at lower frequency is what? RLC series circuit leading power factor na 0.707. 1 by D is the correct option na? Yes or no? Got it? Take 2 minutes break. I will come. We will discuss rest of that. Okay? Take a break. Right guys, welcome back. Completed now. Next question, see that. An RMS voltage of 35 volts is applied to single phase RC series circuit. If the RMS voltage across capacitor is 28, then the angle between the current and the supply voltage. Phase angle is required here. This is RC series circuit. For RC series circuit, see the question, how it is. This is very important here. These type of questions, if you may get it, definitely you may get some confusion regarding this type. He was provided the total voltage and voltage across capacitor. But he wants what? The phase angle. Phase angle also he was given sine inverse given, cos inverse given, tan inverse given, cot inverse is given. That means what? You have to define the voltage across the resistor. That is very important. Even though if you see the observation చూసినప్పుడు ఎట్లా ఉంటుంది పవర్ ఫ్యాక్టర్ అంటే మనకి సిరీస్ ఆర్సీ సర్క్యూట్కి కానీ ఆర్ఎల్ సర్క్యూట్కి కానీ ఆర్ బై జెడ్ ఆర్ ఎక్స్ విఆర్ బై వి కదా. But he didn't provide that voltage across resistor, voltage across capacitor provide చేసాడండి. That means what? VR value, if you want to get it, that under root V square minus what you can take it? VC square, total voltage, nothing but what? 35 square minus 28 square, which is what? 21 volts వస్తుందండి. 21 volts you will get it. అంటే here VR by V. VR by V means what? You can take it 7 3 5 nothing but what? Cos of power factor is what? VR by V. Suppose ఇది తీసుకున్నారు అనుకోండి 21 by 35 వస్తుంది. Once you obtain 21 by 35, what is this value 21 by 35 అంటే? Tell me this. 21 by 35 means here 3 by 5 కదా, అంటే 0.6 కదా. అంటే 5 వాల్యూ ఎంత? కొసైన్ ఆఫ్ కాస్ ఇన్వర్స్ ఆఫ్ 0.6. బట్ ఏమి ఇచ్చాడు ఎక్కడ? he was given that sin inverse of 0.6, nothing but this is not correct. But sin inverse of 0.6 is, whether you are getting that cos inverse of 0.6 is not given. ఇది రివర్స్ ఇచ్చుంటే cos inverse of 0.6 is correct. Suppose sin inverse of 0.8 is given, that is also correct. But these two are not correct. Whether it is check it, this tan inverse of 0.75. Tan inverse అంటే ఏంటి? Tan angle అంటే ఏంటి? Here tan phi is equal to ఇక్కడ tan phi value. Guys, ఈ క్వశ్చన్లో మీకు రిమైన్ రావాల్సింది ఏంటంటే మీరు గుర్తుపెట్టుకోవాల్సింది రైట్ యాంగిల్ ట్రయాంగిల్. వన్స్ యూ నో దిస్ రైట్ యాంగిల్ ట్రయాంగిల్, ఇది tan phi అంటే ఇది విఆర్, దిస్ ఈజ్ విఆర్ అండ్ దిస్ ఈజ్ విసి అండ్ దిస్ ఈజ్ వి. Tan phi అంటే VC by V na, VR na. And that means what? Is it greater than 1 or less than 1? Greater than 1. And here what it is given? 0.75. Nothing but this is also not correct. Once you confirm this one, this is the correct. Are you getting? Yes or no? Tan phi value ఎంత వస్తుంది ఇక్కడ? మనం 28 by 21 అండి, 4 by 3 వస్తుంది. Is it right? But cot phi అంటే ఎంత? 3 by 4. Cot phi, not cos, cot phi 3 by 4. That means what? 0.75. That's why D is the correct answer. Is it okay? Are you there? Okay? Are you getting? Right. Is it clear? Right. See this one. Next question. Is it okay? Option D is the correct one. The next simple here. Based on the here equivalent circuits with respect to here. This is what? This will come magnetic aiding. Magnetic aiding. From that magnetic aiding, we are able to take that network is equivalent network T network. And once you take that equivalent network T network, ఇది షార్ట్ సర్క్యూట్ చేసేసి ఇక్కడ ఈ ఈక్వలెంట్ నెట్వర్క్లో యూ నో దట్ దిస్ వాల్యూ హౌ మచ్ L1 minus M ఫర్ మ్యాగ్నెటిక్ ఎయిడింగ్, L2 minus M అండ్ M. L1 minus M ఏంటంటే 4 minus 2, 2 Henries. దిస్ ఈజ్ 2 minus 2, 2 minus 2, 0. ఈక్వలెంట్ సర్క్యూట్ ఏనండి ఇది. సార్ 0 ఎట్లా వస్తుంది సార్ అంటారు. బట్ దిస్ ఈజ్ ద ఈక్వలెంట్ సర్క్యూట్, దిస్ నాట్ ద ఒరిజినల్ సర్క్యూట్. Now on that time what I can take it, these two are in parallel, total in series with this one. Now by looking into these two terminals, L equivalent value how much? I can take it 2 plus 2 parallel with 2, which is equal to what? 3 Henries now? Yes or no? Are you getting? Which is the correct option? A is the correct one. 3 Henries are there. Okay. Got it? Next one. This is also under magnetic circuits here. The combined inductance of two coils connected in series is 0.6 Henries, 0.1 Henry depending upon the relative directions of the currents in the coils. Nothing but what? He was given that depending upon the connections means, connections and enti here 0.6 anedi aiding and 0.1 anedi opposing. This is aiding and this is opposing. This is opposing and this is aiding. Two coils he was given here and this is aiding. Now from this we are able to define that how much the mutual inductance. I think you know that the combined inductance of the two coils are in series annadu. You know that in series L1 plus L2 plus 2M is equal to what? 0.6 ichadu. L1 plus L2 minus 2M is given 0.1. Now from this once you what we can take it, once you subtract this, you are getting that 4M is equal to, subtract this plus we are getting 4M is equal to, what we are getting? We are subtracting here 0.5. M is equal to what? 0.5 by 4. 0.125 Henry, which is the correct option. Getting guys? D is the correct option. Very good. Right. These are the questions under magnetic circuit and AC circuit analysis. Now while coming to the theorems here, this is also here we have that more percentage. Now 2 to 3 questions you will get it here. 2 to 3 questions or 2 to 3 marks you will get it. 2 to 3 questions or 3 marks to 2 marks you will get it. Now guys, in this one definitely one question you will get related with the maximum power transfer theorem. Believe me, one question under maximum power transfer theorem you will get it, no doubt. Now by taking that here one question maximum power transfer theorem, according to the syllabus we have only these Thevenin's, Norton's and maximum power transfer theorem and superposition theorem here. But these are the question theorems. Millman's theorem also some questions are coming, and you need not go for the substitution theorem, but in the previous examination some questions are given. Anyway, we are going to discuss those, but you need to concentrate only on 4 theorems according to the given syllabus: Thevenin's, Norton's, superposition theorem and maximum power transfer theorem. Okay, now let us take that here. This is under Thevenin's theorem definition, Norton's theorem definition, both we can discuss at a time. And while coming to that here, superposition theorem here. Superposition theorem means what? Circuit can be operated at least two sources. This is the condition for the superposition theorem with the same frequency or multiple frequencies. That's why superposition theorem is very powerful theorem here. Suppose network is operating with the different frequencies, normal analysis is not possible, but superposition theorem is possible. Right? While taking the superposition theorem, we should consider that one source at a time. That is the advantage. Network is going to be simple network. That is the advantage of the here superposition theorem. Dependent sources cannot be suppressed. Endukante dependent sources internal resistance cannot be defined. That's why we cannot suppress. Dependent sources control variable is going to be affected. And the control variable branch also affect అవుతుంది. And SPD is not applicable for the power calculations here. పవర్ కనుక్కోవడానికి ఉపయోగపడుతుంది కానీ డైరెక్ట్గా పవర్ని క్యాలిక్యులేట్ చేయలేము. అంటే we can take it under superposition theorem for current. I is equal to what? I1 plus I2. We can do it here. And voltage you can take it. V is equal to what? V1 plus V2. But power you cannot take it. P is not equal to P1 plus P2. Where 1, 2 ఏంటి? ఇండివిజువల్ పవర్స్, ఇండివిజువల్ కరెంట్స్, ఇండివిజువల్ వోల్టేజెస్. ఆ పైన రెండు చేయొచ్చు కానీ కిందది వీ కెనాట్ డూ ఇట్ దాట్. ఇట్ ఈస్ నాట్ కరెక్ట్. వై? బికాస్ పవర్ ఈజ్ నాన్ లీనియర్. రైట్? ఆ డైరెక్షన్స్ కూడా మనం ప్లస్ ఆర్ మైనస్ తీసుకుంటాం. అందుకని ప్లస్ ఆర్ మైనస్ యూ విల్ టేక్ ఇట్. మ్యాక్సిమం పవర్ ట్రాన్స్ఫర్ థీరం. మ్యాక్సిమం పవర్ ట్రాన్స్ఫర్ థీరం అంటే మ్యాక్సిమం పవర్ ట్రాన్స్ఫర్ థీరంలో 3 కేసెస్ ఉంటాయండి. ఫస్ట్ ఏంటి? డీసీ సర్క్యూటు. నెక్స్ట్ వన్ ఏసీ సర్క్యూటు. లోడ్ ఈజ్ ఆల్సో ఏసీ. థర్డ్ వన్ ఏంటి? ఏసీ సర్క్యూటు, లోడ్ ఓన్లీ రెసిస్టర్ అనమాట. రైట్? దట్ విల్ డిస్కస్ ఇన్ ద ఎగ్జాంపుల్స్. ప్రీవియస్ ఇయర్ క్వశ్చన్స్ ఫ్రమ్ PSUs. See this one. A system is linear if and only if satisfies what? Principle of superposition theorem, principle of homogeneity A and B. Which one is correct? Okay. Very good. Very good, Vamshi. You tell me the answer, Vamshi. This option, which option is correct? Very good. C is the correct one. Next. Tell me this question. Norton's resistance of this. Resistance only. Norton's not, it is not current, not Norton's current. Thevenin's resistance and Norton's resistance are same. And this short circuit, this open circuit, 4 and 3. You know that 4 and 12 parallel means what? 3 you will get it. Is it right? 3 plus 1, 4. Option? Excellent. Excellent. C is the correct one. Rn value you can take it. This is open circuit and this is the short circuit. And finally I can take it 4 parallel with 12. Total in series with 1. 3 plus 1 which is equal to 4 ohms. Got it? Very good. Now let us take this one. Which of the following theorem enables number of voltage source to be combined directly with single voltage source or current source here? Single voltage source or current source. Which one? Compensation is not, reciprocity is not, superposition is not, Millman's? Millman's is correct. Millman's theorem is also called what? What theorem? Single voltage source, single current source. Parallel generator theorem. This is also called what? Parallel generator theorem. Parallel generator theorem. And tell me this one. Guys, tell me, for the network shown below figure, when I is equal to 0, V is equal to 20 volts, when R is equal to 0, I is equal to 10 amperes. If R is equal to 3, what is the value of current I? Very good. Good one here. ఓపెన్ సర్క్యూట్ వోల్టేజ్ ఇచ్చాడు, షార్ట్ సర్క్యూట్ కరెంట్ ఇచ్చాడండి. రెండింటిని బట్టి మనం థెవెనిన్స్ని డిఫైన్ చేయొచ్చు కదా. రైట్? థెవెనిన్స్, దీన్ని కరెక్ట్గా థెవెనిన్స్ రాసేయచ్చా? టెల్ మీ దట్ థెవెనిన్స్ వోల్టేజ్ అంటే ఏంటి? ఆల్రెడీ గివెన్. This is the Thevenins. Nothing but what? This entire network can be replaced with the Thevenins. Now tell me that Thevenins resistance ni, Thevenins voltage ni, we can convert this Thevenins equivalent here. Thevenins equivalent value how much? 20 volts. And Thevenins equivalent resistance means voltage by current, VOC by ISC. Or Thevenins is equal to VOC by ISC, where this one is VOC and this one is ISC. Now what we are getting that VOC ISC? Now, what can I take it here? 3 ohms. He wants to take that, what it is, which is the correct option? Current passing through this one. I is equal to how much? 5 amperes na? Sorry, 4 na? 20 by 5 here. How much you are getting? The 20 by 5, 4 amperes, which is the correct option. Very good. Next, tell me this. A DC source has an open circuit voltage of 30 volts and an internal resistance of 1.5 ohms. A resistive load is connected to the source maximum power. Guys, ఇట్లాంటి క్వశ్చన్ వచ్చినప్పుడు డైరెక్ట్లీ వన్ ఫార్ములా యు ఆర్ హ్యావింగ్ దట్ P maximum is equal to V square by 4RL. V square by 4RL అంటే ఓపెన్ సర్క్యూట్ వోల్టేజ్ అంటే థెవెనిన్స్ వోల్టేజ్. That means this we can take it V Thevenins. This is also R Thevenins also we can take it here. Nothing but what? 30 volts open circuit voltage and resistance. Internal resistance value how much? 1.5. 4 into 1.5. 4 into 1.5 అంటే 6 na? 6 into 5. 5 into 3. 150 watts. This is the way how you have to take it that. Which is the correct option? Sir, small suggestion. ESC chudu babu, all the ESC questions chudu, you will get it. You take the all ESC questions. Who is that? Vamshi. Okay. This is the good question here. Which of the following statement is incorrect? It was given in 2017 AP Transco. Superposition theorem is useful for linear or non-linear. This is only the not correct here. That means if it is, he was given that incorrect statement is only one existing. If you are confident with the non-linear batch for superposition theorem, non-linear element is present, we cannot apply. Then that is the correct one, incorrect statement. And let me check it that rest of all, Thevenin's equivalent network consisting of one voltage source series impedance, no doubt in that. Norton's means one current source. When both load and source impedances are purely resistive, maximum power transfer to HOD is equal to load resistance is equal to source resistance. These are all correct, is only incorrect. Option A is the correct one. Very good. Then take this one. Thevenin's equivalent of the circuit shown in figure is a voltage source of open circuit voltage. And open circuit voltage means what? 6 volts you will get it. Why? Because once you make this is open circuit, 6 and 6 are going to be series. This VOC is equal to equal division అవుతుందండి. Equal division ఏంటంటే 12 by 2 which is equal to 6 volts. But while finding that R Thevenins, ఈ 6 and 6 parallel లోకి వచ్చేస్తాయి. అంటే this is not open circuit. I think you know that we should not make the open circuit while taking the R Thevenins. R Thevenins లో కండిషన్ లేదండి. ఓన్లీ while you are applying that open circuit, that voltage calculation, only Thevenin's voltage ke we should go for that one. Otherwise you cannot take it that. Only for Thevenin's voltage andi. R Thevenin's ki or Norton's ki directly you should go for that. Here R Thevenin's is equal to 6 and 6 parallel, which we are getting as 3 ohms, which is the correct option. Yeah, very good. Excellent. See this one. Source transformation చేసే చేయొచ్చండి. Tell me that answer. Do the source transformation, then do it. Source transformation, do it and tell me the answer. 40 volts you are getting, ma? 40 square by 4 into 8. P maximum is equal to source transformation చేసేసేయండి. 40 square by 4 into 8, 4, 10, 8, 5, 50. Yes or no? 50 watts na? Excellent. 1600 by 32. 50 times. Is it right or not? 4, 10, 140. And 8 5s, 5 into 10, 50. Here source transformation here. By doing the source transformation you are getting. I think it is very simple. I need not take this. Okay, next one. In two-port network parameters, questions, because time is not there. Anyway, till now, whatever the 4 chapters are important, I have given that, and rest of the questions you can take it. And this is the introduction. The syllabus I am giving here. Introduction to this conditions are important, symmetric and reciprocal. Open circuit, short circuit, Z parameters, Y parameters, these are important. A summary. Graph theory is there here. Under graph theory also we are considering this. Right. Graph theory lo basics మీద క్వశ్చన్ రావచ్చండి. ఇన్సిడెంట్ మ్యాట్రిక్స్, టైసెట్ మ్యాట్రిక్స్, కట్ సెట్ మ్యాట్రిక్స్. లాస్ట్ టైం టైసెట్ మ్యాట్రిక్స్, కట్ సెట్ మ్యాట్రిక్స్లో వచ్చేసాడు. ఇది మ్యాక్సిమం 1 మార్క్ వస్తుందండి. దీంట్లో 1 మార్క్, 1 క్వశ్చన్ యూ విల్ గెట్ ఇట్. అండ్ 3 ఫేజ్ సర్క్యూట్ క్వశ్చన్స్ని వాళ్ళు ఏం చేస్తున్నారంటే రిలేటెడ్ విత్ ది ఎగ్జామినర్ ఈజ్ కాన్సన్ట్రేటింగ్ విత్ ద 3 ఫేజ్ ట్రాన్స్ఫార్మర్ తోటి మిక్స్ చేస్తున్నాడు. పవర్ సిస్టమ్ కానీ మెషిన్స్ కానీ చేస్తున్నాడు అనమాట. అండ్ వైల్ కమింగ్ టు దట్ బేసిక్స్ ఇన్ ద గ్రాఫ్ థియరీ, ట్రీ, twig and link, number of links are required, everything in this one question you will get it. While coming to the passive filters ichchadu kabatti 1 question we can expect that. Low pass filter, high pass filter, band pass filter, band stop filter, all pass filter. All pass filter ante entandi, it will allow all the input is output. But what is the advantage? Advantage is what? For phase shift only we are using this. For phase shift, how much the phase shift? All phase shifts are there. Low pass filter, high pass filter, phase shift ఉంటుంది. This phase shift is 180 degrees phase shift here. Input is equal to output, but 180 degrees phase shift వచ్చినప్పుడే దాన్ని ఆల్ పాస్ ఫిల్టర్గా చేస్తాం. బికాస్ వీఆర్ యూజింగ్ ద ఆల్ పాస్ ఫిల్టర్ ఫర్ ఫేస్ షిఫ్ట్, 180 degrees ఫేస్ షిఫ్ట్కి ఎయిదర్ క్లాక్ వైజ్ డైరెక్షన్ ఆర్ యాంటీ క్లాక్ వైజ్ డైరెక్షన్. ఓకే, వీటన్నిటికి 45 degrees ఉంటుందండి ఫేస్ షిఫ్ట్. దట్ వీ విల్ డిస్కస్, రైట్? విల్ డిస్కస్. దిస్ ఈజ్ అబౌట్ ది హియర్ ద ఎంటైర్ సిలబస్ విచ్ యూ కెన్ టేక్ ఇట్. ఓకే, thank you. Any doubts you are having that, you can post it. And thank you. Do the preparation here. Regarding the preparation for this network theory, you concentrate first 4 topics, whatever I have given that. And 2-port network parameters, and graph theory and filters, you do 1 time practice. But rest of the topics, all the topics, you should practice more examples from the previous ESC, previous transco genco questions ni gaani avanni APలో AP transco, AP genco, AP SPDCL, NPDCL ఆ క్వశ్చన్స్ అన్నీ మీరు సాల్వ్ చేయాలి. అదర్వైజ్ యూ విల్ నాట్ గెట్ ఇట్ దట్. And here regarding that, if you enroll with our ACE Engineering Academy, definitely we are ready to provide all the things or all the contents which are required, including the extra syllabus. Additional syllabus is provided by tsgenco. తెలంగాణ గవర్నమెంట్ జెన్కో జనరేషన్ కార్పొరేషన్ ఏదైతే ఇచ్చిందో ఆ మెకానికల్ సబ్జెక్ట్స్ను కూడా వీఆర్ గోయింగ్ టు ప్రొవైడ్ దట్ 100%. And written test we are providing mock test also and test series also. Everything we are going to provide. That's why once you come and join with us, definitely you will get a hope. 100% you will get hope, no doubt in that. మేము ఈచ్ అండ్ ఎవ్రీ కంటెంట్ తోటి మీకు జాబ్ని ప్రొవైడ్ చేయడానికి రెడీగా ఉన్నాము. మీరు రెడీనా? ఇఫ్ యూ ఆర్ రెడీ, దెన్ కమ్ విత్, join with us, then definitely we are ready to provide you whatever the content is required to crack the good rank in coming TS GENCO. Okay, thank you, good night, all the best.